gentlemen, it's my great pleasure as every Monday to welcome you to our lecture series on sustainability in computer science. We have, normally it's only online, but we have today a hybrid meeting. We have a special guest from the University of Economics and Business Administration. It's Professor Sigrid Stagl. You know, I got to know Sigrid a couple of years ago, and I was really impressed. It was kind of beginning of the 10th years when she told about ecological economics and kind of how sustainability, and it was a time there were no sustainability development goals yet, yeah? How sustainability will shape our world. Meanwhile, this is a pressing issue in our everyday life. Sigrid has done, I think, one of the first PhDs in the area of ecological economics at a time where nobody was really on a broad scale working in this area. She is really one of the most famous scientists in this area. I guess you know her from different, just a couple of days ago, she was again in tip 1 and tip 2. So then they need somebody to tell how can we overcome the existing problems with climate crisis and at the same time have a working economy, Sigrid is asked. So I'm very happy to have you here, Professor Stagl, and yeah, it's your floor.
Thank you very much for the invitation. Good evening. I just realized I made a mistake. Normally, my default assumption is that I speak in English. Today I thought we do it in German, so I have German slides. But I'll speak to them in English, and if you write to me, I'll be very happy to provide you with English language slides, because I translated them actually from English to German. So sorry for this, my mistake. Right, the title for today is Planetary Boundaries. Are they the boundaries for our economy? Because obviously Rockström et al. Have in 3 seminal papers in 2009, 2015, and 2023 highlighted the 9 planetary boundaries that from a natural science perspective are really important to keep an eye on. And as an economist, I read this with great interest. And for an ecological economist, this means it's really important to incorporate the relevant dimensions into our economic modeling. The question is, do these planetary boundaries then mean that we have to limit our economy? And this is what the content of today's talk will be. What do limits mean for the economy? First, I need to say something about, well, philosophy of science or pre-analytic vision. Sorry, it will be only one slide, but I think it is important because in ecological economics, we consider the economy as being part of society, embedded in society, and based on the biophysical foundations. This may sound a bit pedantic, but it has really important implications. Because in mainstream economics, most economists would consider, yeah, if you're particularly interested in environmental issues, you work in the field of environmental economics or maybe resource economics, but for the rest, we don't need to account for the environment very much. I think that's wrong. And the whole field of ecological economics says that's wrong, because accounting for the environment of economic transactions is not something for specialists, those who are particularly interested in, but actually in every economic model, you need to account for the environmental, sorry, I'm cycling here and taking the time. For every economic analysis, we need to account for the implications on the environment. And this is sort of the graphical representation of what I've just said, namely, whenever we do an economic analysis, we need to account for the impacts on society and on nature. This means that an economic analysis requires an interdisciplinary team. That is quite a different statement than what you would normally hear from economists. But I haven't got an answer to my question, which I've posed to students and also in seminars over 30 years. Namely, name an economic activity that doesn't have environmental implications. Normally what I hear is something like massages, which doesn't have many environmental implications when we compare it with steel production. Yes, okay, much less energy requirement. But if we think it through, the massage normally doesn't take place in the open air, but rather in a room, in a building. The building needs to be constructed. The building needs to be, maybe lights are turned on, maybe heating is on, maybe cooling is on. The person who gets the massage and the person who's doing the massage, they need to travel to this location. They need to have eaten, probably they've purchased breakfast somewhere. All these are economic activities, of course, and they do have environmental implications. Because depending on how we travel, depending on what food we eat, depending on where the electricity comes from, and so on. So every economic activity has an impact on the environment, and hence we need to have a pre-analytic vision like the following, namely that our economy is embedded in society and based on the biophysical foundation. So that's ecological economics, basically. And ecological economists read a lot more natural science papers than most economists would do. And we watch the data very carefully. And maybe you have seen this already, but this is a graph which you can find at the link below, and it indicates over the years from 1979 to 2024. For every year, you see one line. And the light gray lines are the various years, decades back. Then the orange line, sorry, before I mention the orange line, I should say the dotted lines in the middle, they are the mean and the standard deviation. Yeah? The orange line stands for the daily surface air temperature in 2023. That's significantly above the previous years. And 2024 is in part again above or the same as 2023. So what we can see here, we are in a different regime compared to where we were before. The statistical model, which is represented by the mean of the standard deviation, doesn't capture 2023 and 2024 anymore. Here's the same for sea surface temperature, which is even starker. And so it's the same logic. Every line stands for a year, and orange is 2023, and the red one is 2024. And well, we may say in Austria we are in the landlocked countries, so maybe sea surface temperature is not so important. But as we have learned, the heavy rains that we experienced in September, in part, the reason for it was because the Mediterranean was so hot, hence the air could carry a lot more humidity, even to a landlocked country like Austria, and we experienced floods. So it does matter, even for a landlocked country, and of course, globally, it does matter. So we are in a different temperature regime already. This is just another representation. Global surface temperature increases. And from the latest IPCC report, of course, we know that climate change is very dangerous. It's a close period of time where we need to act quickly. We need international cooperation, although this sounds very difficult at the moment. And the decisions that are taken in this decade matter a lot for the next few thousands of years. Then if we look at what has already been agreed, and which is of course the Paris Climate Agreement which was the ambition to keep the global temperature increase well below 2 degrees, ideally not more than 1.5 degrees. And then if we compare that to the nationally determined contributions and the already implemented policies, we see on the one hand an ambition gap and an implementation gap. So we should reach down there at the lines that are green and blue, but we are up there in the red area, depending on whether it's implemented policies or nationally determined contributions, which are the ambitions basically. The production-based emissions in Austria for a long time only stabilized Yeah? This is what we are normally talking about, the production-based emissions. In 2023, finally, they started to go down by 5%, which is great. Yeah? Roughly that is what we need. That's what we need every year from now on. Something between 5, 7, 8% every year. Emissions need to go down, yeah, in order to reach decarbonization in time. So what we see from this is if ambitious climate policy is implemented, it does show an effect, because that's what we have seen in the last few years. The decades before, there was not so much ambitious climate policy. At the same time, another open, small economy in Europe, Denmark, managed to reduce the emissions by more than 30%. While we were only stabilizing them. So there are different paths. Yeah? Reducing emissions is possible. These are the consumption-based emissions, the orange lines, and they tend to be higher, as you would expect for a rich country, because we tend to import more emissions than we are exporting. We are dealing with a carbon budget, meaning with a limited amount of, a limited volume of emissions that we still have available. And this is where the number that I mentioned earlier, that we, from now on, we need to reduce our emissions every, by 5, by 5% every year. These are the 5% here. Yeah? So if we are okay with reducing the emissions by reducing the emissions in such a way that we stay below 2 degrees, then we need to reduce the emissions globally by 5% every year. If we want to stay below 1%, no, there's a time. Yeah, I'm so sorry. If we want to stay below 1.5 degrees, then we need to reduce our emissions by 10%, 10.7% every year globally. Yeah? So that's just the 5% is what Austria just managed scrapingly, yeah, with a warm winter, I should add. Okay, but also ambitious climate policy. So this is a tough goal. It's difficult to reach, but it's possible. Earth system boundaries, I mentioned earlier, these are the 9 dimensions. You may have seen them. Climate change is only one of them. And the further we go out, the darker the orange, the red gets, the more concerned natural scientists are actually about the respective dimension. There are 3 dimensions, namely ozone depletion, aerosols in the atmosphere, and ocean acidification, where we haven't crossed the boundaries, meaning we're in the green area here, or we have managed to get back into the green area. That's the best one, namely ozone depletion with the Montreal Protocol in the 1990s. So it is possible, even if we have transgressed a boundary, to push back and to go back into this green area, which is a safe operating space. This is an area where change is happening in the environment, but it's to such an extent that it doesn't have massive impacts on other species. It doesn't reach tipping points, meaning we can manage this kind of change. Okay? Because human development always means change of nature. But within the safe operating space, it's an area where we're not harming other species and ourselves with tipping points and so on. Massively, if we are outside, which we are with the other 6 dimensions, it's a really big problem. And what may be surprising if you don't work in the field of sustainability, that yes, of course, climate change, we are outside of the green operating space, safe operating space, because that would be a concentration of climate gases of 350 parts per million concentration of climate gases in the atmosphere. At the moment, we are roughly at 420. So we are outside of that. That's not surprising. We've heard about it. We've learned about it. We're trying to do something about it. What may be surprising is that there are these other 6 dimensions, and some of them natural scientists are even more concerned about, such as biodiversity loss, such as biogeophysical flows like phosphate and nitrogen at the bottom there. Yeah. So actually, we do not only need to account for climate change in our economic models, but these guys also, these other dimensions as well, which is even more complicated. Okay, so biodiversity is a bigger challenge even. for humans and for economists, definitely, because even natural scientists are struggling to measure sometimes how biodiversity can be captured. In all three publications that I mentioned earlier, 2009, 2015, and 2023, the natural scientists suggested a different way of measuring biodiversity, maybe a biodiversity index or an index, a measure that's called human appropriation of net primary production, which basically means just how much biomass are we adopting as a species, are we using as a species, okay? So resource use is another interesting dimension. When you pay close attention, you'll have realized that this is not one of the 9 dimensions, but it's a wide agreement within the field of ecological economics that without reducing resource use, we cannot stay within the biophysical foundations generally. Yeah? So it's like a key to stay within all of these biophysical foundations. For example, extracting resources from the soil requires a lot of energy. Normally, it depends on the energy mix, how much climate gases we will produce when using this energy. Yeah? So extracting resources requires energy, hence generates greenhouse gas emissions. Extracting resources requires land use, hence causes problems with biodiversity, and so on. Yeah, so if we go through, resource use is a facilitator for a larger footprint or a smaller footprint in all the different dimensions. Yeah. Unfortunately, with resource use, of course, the answer would be moving towards a circular economy, so that we don't have the linear production process anymore. We are extracting the resources from the soil, and we are using them, and then we are dumping it somewhere or burning it, trying to burn it, which we can't, of course, with minerals, but it's sort of waste at the end. And ideally, we would reuse what comes out at the end of a production process, and that is an input again into a production process, and we have a circular economy. But the circularity worldwide is only at around 7%. And lately, globally, it has even gone down, which is really problematic. So we're moving there in the wrong direction. The Austrian government has a very ambitious and very well thought through circular economy strategy, which they have suggested. And so it was adopted by the still current government. And it is also a basis for the National Energy and Climate Plan. So they have done their job. They are starting with the big levers like the building industry, other industries. Yeah. So we know how we can reach a circular economy, but it hasn't been implemented yet, largely. Okay, but it needs to be done in order to stay within the biophysical boundaries. Then economic growth, the elephant in the room. And I'll talk a lot about the economic growth. Is economic growth actually something to aspire to still? Is that something we want? Or if we have economic growth, of course, that means more resource use, more emissions, more biodiversity loss, and so on. So is that actually a bad thing? So I'll talk about that a lot now, the next 20 minutes or so. So economic growth is one of the sustainable development goals that we have heard already in the introduction. I'm unhappy that it's actually called economic growth, because if they had asked me, I would have argued for economic development. Economic development is, of course, something we want, but whether we need economic growth for that or not is a different story. My take on it is for people who live in poverty, for households who are poor, for regions, for countries who are poor, of course, we need more income for them. It's not enough to have more income, but it's clearly one avenue to get out of poverty, to have more income. For rich countries, households, people, if we are interested in efficiency to achieve well-being, because in the end, that's what we want to achieve, to have more income is a very inefficient producer of well-being above a certain threshold. Yeah? And then we could say, well, we're just producing more and still go with the well-being still going up a little bit. But we have the massive problem that the economic growth is coupled with resource use, is coupled with emissions and all the other environmental problems. Hence, the question is, can we afford to produce so little additional well-being and cause so many environmental problems on the way? That's the challenge that we have. So we need to look at the empirical evidence where we stand there. But I would rather talk about economic development. And for me, economic growth is a means to an end, not a goal. And I think we should name the goals. But economic growth is, of course, the main goal for economic policymakers, and for a good reason. Because there is very little economic analysis on how we can organize important social institutions such as labor markets, pension systems, social security systems, even education systems, if we don't have economic growth. Because most of these institutions were set up at a time when it was clear, well, we started out in poverty after World War II, which is when many of the rules that we are adhering to nowadays were written down. And we were expecting that next year we have higher income than last year, and then higher income again. So that was sort of built in. But how does a labor market work well if we have increasing productivity, but not more GDP? If we have increasing productivity, means that we need fewer workers next year in order to produce the same GDP. That means systematically we are producing unemployment. That's really problematic. That's economically problematic, but also socially problematic, because people in a work society as we are, it's a way of partaking in society, to be a full contributor to society. It's not just that I get my income from it, but it's also a way how we are valued. So to produce unemployment is not a good idea at all. But what kind of social institutions could we have? How can we regulate a labor market if we have productivity growth? And of course, we want to produce with better technologies if we have them. If we don't produce more next year compared to this year. Well, the first question is, what kind of productivity growth do we have? What kind of technology do we have? Is it resource saving? Or is it labor saving? In the past few decades, labor was so much more expensive compared to resources, so there was a lot more incentive to develop labor saving technologies compared to resource saving technologies. So actually what we need is a change in the relative prices in the input factors, make resources more expensive and labor cheaper, so that there is more of an incentive to produce technologies, to develop technologies that are resource saving rather than labor saving. So that is one lever that we can use. And for example, a CO2 tax is one of such a lever in order to make the environmental goods more expensive. Another one could be, well, 40 hours per week or 38 hours per week is not written in stone. If we require less volume of work for producing the same amount, see that as a success. It's great, isn't it? So slowly we're reducing our working hours as we have better technologies, and so on. But we need to discuss this. We need to have a suite of methods that allow us to have a successful economy with a functioning labor market that doesn't produce unemployment. But what kind of rules, what kind of institutions do we need to implement? My institute is working on this question because I started out as a labor economist, so I know enough about labor markets in order to be confident to contribute something. I know nothing about pension systems, social security systems, and so on. But this also needs to be worked through. How can we have a functioning pension system even if we don't have economic growth in a rich economy, for example? And until we have answers of this sort, it's quite rational for policymakers to work towards economic growth. So it's also a task for economists, for scientists to do better. So what we are hoping for is the golden path would be if we could continue to produce as we have done in the past, Economic growth is sort of the goal because that has worked for the last few decades. But at the same time, we're reducing the emissions massively while we are increasing GDP. And well-being, we even want to increase that further. Yeah? So well-being goes up massively here. GDP goes up. Resource use, we are stabilizing. And emissions, we're reducing. All at the same time as we are, where am I here? As we are moving over time in this direction over here. That's the time arrow in this direction. Yeah. Right. So that's conceptually what we are hoping for. The question is, do we see that empirically? First, we need to distinguish between relative and absolute decoupling of economic growth from environmental impacts. Relative decoupling means that per unit GDP, we are using fewer resources or producing fewer emissions, which is good. Better technology, greener preferences, stricter environmental regulations, they all lead to this effect that per unit GDP, we use fewer resources, we produce fewer emissions. But now let's think it through. We're producing fewer emissions because of better technology from one year to the next year by 2%, which is great. But we're producing 3% more. What happens to overall emissions? They go up. And that's one of the main concerns that why ecological economics was started, because in mainstream economics, it's efficiency went up, GDP goes up, it's twice, thumbs up, all is good. And ecological economists have argued, when working with natural scientists, like, wait a minute, but the absolute emissions are going up. That's a problem. But the economic models just didn't show that because they do not have absolute limits. They do not have the absolute volume of emissions in the economic model. Okay. I was actually once asked by the ministry, then it was called the environment, it's about 10, 15 years ago, no, 12 years ago, to accompany a mission to the OECD. My main task was to ask critical questions. So I was like, sounds like an interesting task, I can do that. And so it was the Secretary General of the OECD gave a presentation, and he had a new well-being index. So he presented that, and it was going up, all good in the OECD countries, and the material efficiency was going up. So per unit GDP, fewer materials were used. Emissions intensity went down. So per unit GDP, fewer emissions were produced, and GDP went up. And it was all thumbs up. And you even have the little icons there, like thumbs up. It was all good. And everybody's like, oh, fantastic, it's all going well. That was my task, to pose critical questions. I was like, what about overall emissions? What about overall resource use? It was literally, he didn't have an answer for it. And some of the technical people in the background was and then we had a really interesting discussion about it. But until 10 years ago, that was not on the radar. But for the planet, of course, what matters is the absolute volume of emissions. It's not per unit GDP what matters. So we need to also have the absolute decoupling, not just the relative decoupling. And it's an empirical question of what we observe. So let's check it. Decoupling of air emissions in the EU, yes, it's going down. GDP over time went up in the EU during this period, but the emissions, air emissions went down. This doesn't mean that we've completely gotten rid of them. It's still every year 7,000 people die prematurely in Austria because of air emissions, which is a significant number. Too many, I would say. Well, it's not a problem of the 1980s and 90s. It's still nowadays problem, but at least the emissions are going down while GDP is going up. In the EU, it's happening. In Asia, it's starting to level off. Yeah. So here we see they still went up and now they're leveling off. Can you see that? Yeah. So they're starting to stabilize in Asia. Okay. If we look at resource use, if GDP goes up, resource use is starting to come down or has started to come down as of 2010. It depends a bit on what indicator we use, whether we use domestic material consumption or the material footprint. We're on a different level. and it depends also on which country we're looking at. My institute, Ecological Economics, is part of a small handful of institutes worldwide that is doing biophysical accounting, and my colleague Stefan Gillium is leading that group, the Global Resource Use Group, and they are they've built up and maintain this database, materialflows.net, which you can access. It's free to use for everybody, and you can go through and identify which countries are actually, with regards to which indicator, have managed to relatively decouple, absolutely decouple. It's a mixed bag at the moment. If we look at material footprint here, and the green area is the area, every dot is a country, and the green area is the area of those countries that have managed to absolutely decouple. Yellow is the area of the countries that have managed to relatively decouple GDP from resource use or material footprint in this case. And in the red area is where no decoupling is happening yet. So material footprint goes up as GDP goes up in the same amount, meaning technology doesn't play an important role there. Again, it's quite a mixed bag. Austria is on the fence between the relative and absolute decoupling. So we are by no means an exemplar there. And here are some countries that would be interesting to look at. Here's another representation, because quite often we hear, or more often these days we hear, oh, it's possible to have GDP growth and reduce the emissions at the same time. And then we see graphs like this for every country. I mentioned earlier Denmark, which has increased between 2005 and 2020, has increased GDP by 8% and reduced the emissions by 41%. Already the use of data from 2005 is a very strategic choice. The convention in science is actually to compare all emissions to 1990. It could be 1987, it could be 1993, it doesn't really matter, but it's important to always refer to 1 year. And way back, it was decided it should be 1990, just to make it comparable. Using 2005, which was sort of the peak of many European or rich countries' emissions, is already a strategic choice, because I said Denmark reduced the emissions by over 30%. If you choose 2005 as the reference point, it's minus 41%. So with all this decoupling debate, we see a lot of strategic use of statistics. We see these looks like a lot of countries, but not all countries have decoupled. We don't see them on here. The time period is chosen strategically. What kind of emissions is chosen strategically? So we need to look either systematically or not let the argument, not accept the argument. But just to look at something like this, a few countries for some time period, which we know is strategically chosen for one environmental indicator, that's not good enough, I would say. So, for example, colleagues of mine, Ashad Nakwi and Clara Zwickel, a few years ago used a consistent data set for 18 EU countries for 6 economic sectors and 6 environmental impact factors. And they identified what kind of decoupling have we seen in these countries systematically. And what they found is that an average EU country received some sort of decoupling. So normally in Europe, at least in these 18 countries, decoupling has happened, some sort of decoupling. So stricter environmental policies leads to decoupling. That's good. The decoupling improved between 2001 to 2008 compared to 1995 to 2001. So that's good. But those who were already decoupling in the earlier period decoupled more in the later period. And those who were already laggards in the earlier period remained laggards. So the discrepancy became larger. So it's not that we're all gravitating towards the same path, but it's rather those who were sort of the avant-garde, they are still leading the way, and the others are still lagging behind. Okay. And the reductions are too small we can only experience them with a certain time lag. So yes, some good developments, but not sufficient. Okay. Oh, see here, I forgot to translate everything, which is an advantage now. Another study, Haberl et al. From the University of Life Sciences here in Vienna. They reviewed over 800 articles, which were dealing with the decoupling of GDP from resource use and greenhouse gas emissions, and they found that the absolute reduction of resource use and greenhouse gas emissions is not sufficiently found in these studies. So we need to have stricter absolute reduction targets and sufficiency-oriented strategies, because what we have observed in the past systematically from these 800 studies is not sufficient. 4 days ago, another study was published, Zioga et al. And ORF said economic growth is possible while emissions are being reduced. Interesting. Okay, I need to look at this study. Went through with my students, and the abstract is a bit strategically written because it may lend itself towards that conclusion. So we shouldn't blame the journalists. Also, it's not open access. So we even at WU, we didn't have a subscription for the journal, although it's nice, it's a good journal. So we had to purchase it. And when you go through the whole article, the story is much more differentiated. Let's look at it. Here we have different periods, 1990 to 2000 in the top panel, then 2000 to 2010, and 2010 to 2020 in the panel C. And the world regions are colored by CO2 intensity. The darker, the higher the CO2 intensity, which is of course bad. So very roughly, only when looking at the colors, we can see this doesn't come through very well. But when we look at the original graph, it was no big change between 1990 to in the first decade compared to the second decade, but some improvement to the third decade. So from 2010 to 2020, carbon intensity in general went down, which is good. This is relative decoupling. Per unit GDP, we are generating fewer emissions. That's good. Yeah. So we're moving in the right direction. Less really dark red world regions visible. Then here we have relative decoupling, absolute decoupling, or intensifying decoupling. Absolute decoupling is blue. Relative decoupling is green, yellow, and intensifying coupling is red. So what we see in the first one, there is not much absolute decoupling. Second one, more absolute decoupling. Third one, a bit more even. We're moving in the right direction. We may start putting our thumbs up. Third panel, third graph shows in which year are the countries at that rate at which they are decoupling at the moment expected to reach net zero. And here we have, well, light blue is 2020. Whoa, fantastic. 2050 is the gray area. Orange is over to 2075. Dark orange is 2100, and when it's red, it's 2150, 2200. So it should be only blue or light gray here, because that's, of course, what we have agreed worldwide to decarbonize by 2050. But we see a lot of red here. So while we are moving somewhat in the right direction with the decoupling, yeah, even seeing some absolute decoupling, but much too slow. The gray for Africa, the data sources aren't good enough, so we don't have enough information about that. Okay. But the dark red is really problematic because the decoupling, the net zero happens much too late. So with all this different kinds of analysis, the evidence is, yes, there are steps in the right direction happening with regards to decoupling, but we cannot say that we can afford economic growth for rich countries, and that we would be able to be confident to reach carbon neutrality in good time. No, this is not what we see. So we need a systematic in order to talk about decoupling, not just is decoupling happening, yes or no. We need to distinguish between the relative and the absolute decoupling, but also is it sufficient? So what we see here is GDP is indicated with BIP, Bruttoinlandsprodukt. If the graph, the line above would be an intensifying coupling, we see that rarely, but sometimes we do observe it. Yeah. Along the lines of the dotted line, GDP, it would be the change in the environment happens at the same extent as GDP goes up. Relative decoupling means GDP goes up more than resource use or emissions. Yeah, so that's the purple line here. And then if we move towards absolute decoupling, GDP goes up, but the emissions go down in absolute terms, or resource use goes down in absolute terms, but that's not sufficient, because the question is also, does it go down enough in order to keep us within the planetary boundaries? And for that, we need to have the emissions or the resource use go down sufficiently, absolute decoupling to a sufficient extent. Yeah. So conditions under which green growth can happen, it actually requires several conditions to be fulfilled. First of all, decoupling of production and consumption must be absolute, not relative. Because otherwise the environmental damage increases. Second, the decoupling must refer to all relevant environmental impacts, not just CO2 emissions. Third, decoupling must happen everywhere in our own country as well as abroad, because otherwise we just send our industries abroad and it's somebody else's problem. But globally, of course, that doesn't make any difference. Fourth, decoupling must be fast enough in order to avoid an ecological collapse, meaning to stay within the biophysical boundaries. And fifth, the decoupling we must be able to keep it up. For example, we have seen for some countries, such as Japan, that resource use went down really nicely over some decades, and then it started to recouple, like an N-shaped development. So we need to also be able to keep it up. Okay. So actually, green growth requires a lot of conditions to be fulfilled. But quite often it's like an easy strategy for policymakers to argue, well, if we can't have economic growth and environmental quality, well, let's have qualitative growth or sustainable growth or green growth. Is all the same thing, and it's very poorly defined what actually is meant by it. So these are the conditions that need to be fulfilled for green growth actually to be sustainable. What we are arguing in ecological economics is, well, maybe we need to think about the economy in a different way. But the goal is not economic growth, but the goal are, well, several goals that society has. And Kate Raworth, who wrote a book on donut economics, because that looks a little bit like a donut, she put in the middle goals that were democratically processed documents from different governments, such as to provide sufficient water supply, good quality water supply for the population, provide healthy food, good health, education, income, peace, justice, political representation, social justice, dwellings, gender equality, being part of social networks, energy, and so on. Yeah? For a social scientist, that is really hard to read because it doesn't have a theoretical underpinning, because it comes from policy documents. But she worked at Oxfam at the time, and she said she didn't want to put her favorite goals there because that's not what matters. And this is why she took the overlapping goals from several countries' policy processes, policy documents, which is legitimate, of course. So this is what we are striving for, to provide for the population. Yeah, and that's, of course, well, we could say these are the goals of an economy also. Yeah? This is what we want to provide for the population. On the outer rim, we have the biophysical boundaries again, yeah, the planetary boundaries. And then in the green area here is, well, societies differ. Yeah, some societies make different choices than other societies, and that's good and well. Yeah, we don't want to have a blueprint for all societies to be the same. Yeah, so this is sort of the space for societies to be different here in this green area here. Yeah. We defined it slightly. We put human flourishing at the center, such as need satisfaction or subjective well-being, life satisfaction, or the capabilities approach from Amartya Sen. So this is just like different ways of conceptualizing human flourishing from a social science perspective. We've also suggested to have the biophysical boundaries at the outset, and then we need to have also negotiations, governance processes, an interpretation of scientific uncertainty of all these natural science inputs, because of course not natural scientists make the decisions for society, but rather democratically legitimized decision makers need to interpret the insights from natural sciences. And that's what this fuzzy area, the blue one, is here. Yeah. Then there's the safe and just space for humanity. And maybe that is a starting point for a different way to think about an economy. Former colleagues of mine from the University of Leeds looked at this empirically, and it's not exactly the same categorizations in the center, because they took what was empirically possible, where they had data for the countries in the world. What we see here is in the center, when the sort of the pie in the middle is blue, then the needs are met for the population. If it's red in the center, the parts that are red means inadequate provision for people. Yeah? So here with Bangladesh, we see it's a poor country. It's not surprising that in some dimensions there is inadequate provision. Not all needs are met for the population in Bangladesh. On the positive side, on the biophysical side, they are not transgressing any biophysical boundaries. But still, we can't say that's a success story that we want to strive to copy and learn from, because it's a poor country and they're not providing sufficiently for their population. The next country, Albania in this case, in terms of need satisfaction, it's already better than Bangladesh, but already at that level, several dimensions are transgressed. And here we have Austria, need satisfaction, at least on average, possible, full need satisfaction, but in important dimensions, significant transgressing of biophysical boundaries. Yeah? So the problem is we don't have a country that we can aspire to copy, but we need to walk the path as we go. And every country needs to develop their own way of meeting the needs of the population and staying within the biophysical limits. So this is why we're talking about post-growth, degrowth economies, or I prefer it to talk about the goals that are actually matter, such as the different human needs to satisfy those. And then if we do that, economics becomes the science of social provisioning. Yeah. The science of social provisioning, sorry, wrong direction. Science of social provisioning means that the goal is to provide adequate infrastructures to make it possible for people to satisfy their needs in a sustainable way. And if we use the capability approach from Amartya Sen and Martha Nussbaum as a conceptualization, we could also say to give everybody the freedom to make the choices to live in a sustainable way. Yeah? And this is not an economy, this is not a society that we live in at the moment. We still need to build up better infrastructures. And if I can make a reference to the current discussion about the climate bonus, because I think we need to strive for no longer needing a climate bonus, because at the moment it's just compensating those households who cannot make the choices, such as have sustainable transport or sustainable heating or excellent insulation and so on. So the goal should be that everybody can live in a house that is well insulated, that has a sustainable heating system, that everybody has the choice to use sustainable transport, and then we don't need a climate bonus anymore. And that's actually what we need to work towards, not to get rid of it now because we need to consolidate our budget. And the first thing that we think about is something where climate is on, which sends the signal that actually the climate measures are luxury. The wrong signal, I think. But to strive for no longer needing a climate bonus, I think that would be a good path. But we need different infrastructures so that everybody has the freedom to choose to live in a sustainable way. At the moment, that's not the case. Another question arises: how much wealth can we afford? That's a question that Ingrid Robijns, she's a professor at Utrecht University, a philosopher and economist, poses. And I think it's a really interesting question, on the one hand from an environmental perspective, but also from a perspective of democracy. And maybe we'll see some interesting things tomorrow in the election in the US, where of course it's necessary to be rich before you can become part of a democratic process. Yeah, that's a book recommendation that I would like to add, and these are just my references, and I thank you very much for your attention.
Thank you very much. Amazing. Wow, I would have a lot of questions. I guess you can also then pose questions from the chat. But before I take the privilege to ask my question, what was really, there were a lot of numbers where I was kind of astonished about, but what really has broken my attention was this percentage that circular economy was the reuse, yeah, of resources was going down from 9% to 9 point something to 7 point something. Wow. When I think of how kind of what we, in our small universe in the sense of what we teach at the universities, how we should behave in our daily life, collecting and separating the different, waste, which is not waste, but material, how can this go down globally? Mm-hmm. Are we kind of in a, this special privileged society who do their, plastic and glass and metal separation, but all the others don't do it?
No, actually not, because even countries like Kenya, for example, in some regards, they are more progressive than us, for example, trying to reduce plastic from the start, yeah? not just to recycle it, and so on. So even some African countries have been actually quite leading the way in some dimensions, certainly not in all dimensions. Not all countries have functioning recycling systems, of course, waste collection and then recycling. But the big volumes there are, for example, the building industry. And we're still demolishing way too many buildings and not reusing these materials. Or when we're rebuilding roads, for example, yeah? So the big volumes, they are not being reused. And compared to these big volumes, our efforts, which are good and important and necessary, but they a bit disappear.
Another question which kind of popped up, it was really in the, as when we look at, what was 2,200, we are in the zero emission area. I guess we are dead until then.
Yep.
I don't want to be dystopic, but
That's way too late.
What? How can we tell our rich people, our politicians, the business people that we have to do something?
Yeah. I mean, in Europe, we do have provisions. I mean, on the one hand, we signed the Paris Agreement, which is international law. It's not just a document, the policy document that we signed. It is international law, so it does matter. And of course, in Europe, we also have the European Green Deal. We have the EU emissions trading scheme, where for a long time, the price was really stagnant at around €9 per ton, which means nothing. Yeah? You don't feel that. Now it's at around €90 per ton, so it starts to make an impact. The Austrian version of the CO2 emissions tax is still at 45, but it goes up every year, and it will lead into the EU emissions trading scheme. And then on the European level, there is also a discussion, or actually a plan, to implement emissions trading for the other sectors which are not captured at the moment. The expectation is that within a few years, the emissions price will go up to 200 or 300 euros per ton. Then we start to feel it, and these will be the real mechanisms where it will matter economically, and hence decisions will be made in a different way. And that's where we need to get to. We also need to signal financial actors, investors, for example, which are brown investments and which are green investments. Where is there a danger to invest in stranded assets? Stranded assets mean these are assets that somebody purchased, but they cannot be harvested in future. They cannot be used in future. That's a bad investment, of course. So also to signal on the financial markets, to report the economic success of companies in multiple dimensions, including emissions, including material consumption, all of these different ways of having institutions in place so that economic actors can make better decisions. All of this is necessary. The carbon price alone will not do it. It's necessary, but not a sufficient condition. We also need other measures, which are, for example, nicely detailed in the National Energy and Climate Plan that Austria sent to Brussels. And which we will have to adhere to. And if the next government chooses not to implement the measures that are in that plan, they will have to come up with other measures, but to still reduce the emissions accordingly, because there is an agreement amongst EU countries. There is a global agreement with the Paris climate agreement. It's not a very strong agreement because the sanctions are not very strong, and countries can just choose to leave. So we'll see what happens tomorrow. But normally it should hold. We should have international cooperation. So I would say the glass is half full, but we need to make it completely full so that we have all countries to decarbonize by 2050, 2070 at the very latest for the poor countries, but 2040 for the rich countries.
Just a final question in the first round. Your university, our university, we are in the excellence cluster bilateral AI, which is great. You have great scientists, we have great scientists. I have read that ChatGPT will use as much energy as the usage of ChatGPT will use as much energy as Argentina in a couple of years. What is your position to that? Now we are in this relative and absolute decoupling. I didn't know this. I have really, but of course I've learned a lot, but this is really something which also, which I will keep. How do we go about the development of artificial intelligence as part of our daily life in all areas? Teaching, research will change totally, I'm pretty sure. Economy.
Like with every new technology, this is a powerful technology, it has a lot of potential, it also has problems. The energy requirement is massive. At the same time, we have a lot of solar radiation coming to the planet, which we don't harvest at the moment. Even we only harvest a very small amount of that. But to harvest the solar energy requires, of course, material use, and that needs to be produced again, and that causes a lot of problems again. So even green electricity generation is environmentally harmful. Not as environmentally harmful as fossil fuel use, of course, but still. So we need to be careful about it. We probably, for environmental reasons, but maybe also for democratic reasons, we need to have a discussion about what rules we want to give artificial intelligence. But I think it's a very big discussion, but I think also for environmental reasons, we need to have that discussion. But in general, I think we need a lot more green electricity. Even just transforming from combustion engines to electric vehicles will increase the amount of green electricity required by 18% compared to the current green electricity generation, which is significant, but it's not as much as you might expect. But that's because using e-mobility is more efficient than combustion engines, of course. But then we also have moving from using gas, fossil fuels, coal, oil, and so on for heating to heat pumps, which we need, again, more green electricity. So we need a lot more green electricity. And then we need to be clever about it. And we shouldn't do things like synthetic fuels for cars, because that means working against physics, but rather be clever. Only use e-mobility, first use e-mobility instead of synthetic fuel, and only use e-mobility where it's not possible to do otherwise, such as active mobility, cycling, walking, or using public transport, because that is the much bigger lever. So a lot more green electricity can be generated, but we need it for a lot of different demands. And we need to use the levers that we have at our hands to reduce the energy requirement in order to stay within the biophysical boundary of climate change.
Are there questions?
Economic growth is a means to a goal. Do sovereign states not clearly show every time anew that the economic growth really is the goal?
Yeah, I mean, economic policymakers do at the moment see economic growth as a goal. Because if they manage to achieve economic growth, normally they can pat themselves on the shoulders like, mission accomplished. Not really. Because they assume that if they have economic growth, they have also achieved all the other societal goals. Empirical social science research shows that some of the societal goals are positively correlated with GDP. Some are negatively correlated with GDP, and some are not at all correlated with GDP. Positively correlated with GDP is better health, for example. If we're better educated, we earn more, then we have better health normally. That's positively correlated with income. And one that is negatively correlated with income is the environmental factors, as we've just explored today. And others which are not correlated with GDP is, for example, political participation in many countries. So it's too rough to just assume just when we are delivering GDP growth that we are also delivering all the other goods that we want to achieve within a society. We would argue from a post-growth perspective that we need to name societal goals and aim to achieve them directly and not via the detour of GDP, because that is inefficient. So that is a real rethink of how we think about the economy. Is the goal mostly GDP growth? And that is a paradigm at the moment. I would even say it's a creed, because in my discipline, economics, if I say our goal is not GDP growth, it's like, be a traitor. It's the body language changes when you're discussing with economists and so on. But we have thought about that long and hard, and we think that it's a detour that we can no longer afford. It's a means to an end, GDP. It's not a goal in itself. And we should name the goals that we want to achieve and then try to address them directly.
there another question? No. But you have, you said it's, you get problems when you discuss this. I mean, your former rector, Bartelt, is, I think, is a very bright guy, and now as a head of the fiscal council, he's really has to, I think, also take care of, you know, the development of the country. Do you know what is the his position in this area?
We had a discussion about this just a few months ago in the parliament, because there was a conference organized by a few parties on post-growth. And he was invited. I gave a presentation which was quite similar to the one that I gave today. And he was also present there. And I know from personal discussions with Sabal that he has thought long and deep about environmental issues. Of course, social policy is his field, but he has a deep concern for environmental issues. He's still attacked in this event, one of my PhD students, who argued against pursuing GDP for rich countries. So it still requires some rethinking. And I think there are younger PhD students who are really pushing the field, and us older economists, we need to sort of catch up. It's a new way of thinking that is very much pushed by young researchers, but I think that's necessary in order to really adhere to the societal goals and not stay within our old thinking. But it's really a paradigm change, and paradigm changes don't come easily.
And it has to come in a global way, no? As if only Austria, only the EU would dies, but it wouldn't really matter, I guess.
But it does matter what we show, because of course many poorer countries have always been sort of watching what the richer countries have been doing, and they have tried to imitate a lot of what we were doing. I think the richer countries now need to lead the way and show how it can be done without economic growth, or how it can be done when we are pursuing the societal goals, staying within the biophysical boundaries, and whatever comes out with GDP comes out. I'm not against GDP growth. I'm not pro GDP growth. For me, it's not a goal. You know? But we need to show that we can run an economy successfully within the biophysical boundaries and meet the human needs. If we can't do it in OECD countries, I think it would be completely inappropriate to ask from poor countries to lead the way.
So then I say to our guests in the universe, thank you for attending. It was great to have you here. Especially thank you to Professor Stagl. This was really an amazing presentation at a technical university to understand how the kind of the global parameters really work. And I guess we have it in our hand to develop in a better way. So thank you very much. Goodbye.